Hello and welcome to the third video on Maxima Minima brought to you by Gofodu.com. Let's start right away with the question. We have product given to us as constant. Product of x and y is 12 and minimum value of sum is to be calculated. AM is greater than or equal to GM, where GM is fixed and minimum value of AM is to be calculated. Now we have 3x plus 4y, 3x plus 4y in the left. So AM will be 3x plus 4y upon 2. And for GM, I will write 3x into 4y whole raised to 1 by 2. Right? Now can we create 3x into 4y in the right? Yes, we can. This is nothing but 3 into 4, 12. 12 times xy, and xy is given to us as 12. So basically, this is 12 times 12, that is 144 raised to 1 by 2. So 3x plus 4y is nothing but this 2 will get transposed to the right. Root of 144 is 12 only. 2 times 12 is 24. Easy, isn't it? Next question. It has two parts. Let's solve the first one. Minimum value of this sum is to be calculated, but the product is not given to us. The product of these two terms is not given to us. We have to find minimum value of this sum. Now can we get the product by actually multiplying these two terms? X multiplied by a upon x is constant. X and x will get cancelled and we'll get a as the product. So the product is constant. That means we can get the minimum value of this sum. AM is greater than or equal to GM. AM is what? X plus A upon X upon 2. Sum of the two terms upon 2, which will be greater than or equal to GM. That is X into A upon X whole raised to 1 by 2. So X plus A upon X is greater than or equal to, this 2 will go to the right, X and X will get cancelled. 2 times root A is the minimum value of this sum. Important thing to note in the question, to note in every question that we have solved so far, is that all the variables involved, all the terms involved are positive real numbers. Okay, then only we can apply AM greater than or equal to GM. Otherwise, we cannot apply this property. Now comes the second part, and these two parts are independent of each other. So don't use this information, this result that we have derived for second part. Okay, these two parts are separate. Now we have x square and a upon x as the two terms. If we take the product, I have two x's in the numerator but only one x in the denominator. So this x and this one x will get cancelled and I will get ax as the final product, which is not constant. Okay. So to cancel out these two x's, I will need 2x in the denominator. And to create one more x in the denominator, we will have to split this term as a upon 2x plus a upon 2x. Okay, a upon x can be written as a upon 2x and a upon 2x. So for AM, we will have sum of three terms, that is x square plus a upon 2x plus a upon 2x. This is the required value for our second part. And AM is what? Sum of these three terms upon 3, which will be greater than or equal to GM, that is x square into a upon 2x into a upon 2x whole raised to 1 by 3. This x and x will get cancelled and my required sum x square plus a upon x will be greater than or equal to 3 times a by 2 whole square raised to 1 by 3, that is a by 2 raised to 2 by 3. This is my final answer. So this trick is very important, breaking a term so as to get the required product. This is very important. Moving on to the last question of this video as well as this topic. Now a little knowledge of sum and product of roots in a cubic equation will be required here. Let's say the roots are alpha, beta and gamma. Now sum of roots, alpha plus beta plus gamma will be minus of minus m upon 1, that is m, and sum of the product of roots taken 2 at a time, that will be alpha beta plus beta gamma plus gamma alpha is what? N, and product of roots is alpha beta gamma, that is 27. Now, most common mistake that students do here is that minimum value of m plus n is asked. So, they write m plus n upon 2 is greater than or equal to mn raised to power 1 by 2. Of course, we can get minimum value of m plus n from here, but how will you get the product of these coefficients m and n? How will you get m into n? So, this approach is wrong. Rather, we should use this knowledge of cubic equation. Now, can we minimize both m and n individually? So that m plus n minimum will be what? M minimum plus n minimum. We'll minimize m and n both individually. Now, I see sum of alpha and beta and gamma, and I see product of alpha, beta, gamma. So, I'll write am greater than or equal to gm. For am, I have alpha plus beta plus gamma upon 3, and for gm, I have alpha, beta, gamma raised to 1 by 3. This sum is what? M upon 3 is greater than or equal to, this product is 27 raised to 1 by 3 is 3 only. So, m is greater than or equal to 9, minimum value of m is 9. For n, we have sum of these 3 terms. So, for am, I will write alpha beta plus beta gamma plus gamma alpha upon 3, and for gm, I will have this product alpha beta into beta gamma into gamma alpha raised to power 1 by 3. This sum is what? N. So, n upon 3 is greater than or equal to, I have alpha multiplied by itself 2 times, beta 2 times and gamma 2 times. So, this is nothing but alpha square into beta square into gamma square, that is alpha beta gamma whole square. Alpha beta gamma is 27 whole square raised to 1 by 3, that will make it 2 by 3. So, n is greater than or equal to 27 is what? 3 cube. 3 and 3 will get cancelled. I will have 3 square in the right hand side. This 3 will transpose to the right, making it 3 cube in the right hand side. So, n is nothing but 27. And m minimum is 9, n minimum is 27, m plus n minimum is 9 plus 27, that is 36. One more thing to note here is that minimum value of m is 9. For m to be 9, this am should be equal to gm, and this relation occurs when all the terms are equal. Am is greater than or equal to gm. Equality occurs when all the terms are equal. In general, we can say product of 3 terms is constant, then their sum will be minimum when all 3 are equal. Similarly, if product of 5 terms is constant, their sum will be minimum when all 5 are equal. And one more thing, sum of products of terms taken 2 at a time, 3 at a time, 4 at a time, all will be minimum when all 5 terms are equal. Okay, that pretty much wraps up this topic. One important thing I want to discuss, I want to talk about is that what are the triggers, what are the clues that will let you know that the question is from this topic. There are many formats from which questions can be asked, and many a times it is not evident that the question is from this topic. So these clues will help you figure out. These are the clues to identify if a question is based on this concept, am is greater than or equal to gm. So first clue is that in the question it will be mentioned that the terms are positive real numbers. A, B and C are positive real numbers. Now this could be mentioned directly or indirectly, like y is greater than 0, that means y is positive, and x is greater than or equal to y, that means x is also positive. Okay, so it could be mentioned directly or indirectly, but for this property all the terms should be positive real numbers. Second clue is that sum and product of the terms will be involved. with one thing given as constant. We have solved many such questions, right? Third one, maximum or minimum value of an expression is asked. Now there are chances that if maximum or minimum value of an expression is asked, the question is based on this concept, AM is greater than or equal to GM. Fourth one, now there can be multiple choice questions which will appear totally unrelated, like value of so and so expression can never be. Then there will be 4 options. Okay, in such questions you will have to find the maximum or minimum value of the given expression and mark the option which is outside the range. For example, let's say x plus y is 6, x and y are positive real numbers, and x, y can never be. And the 4 options are 7, 8, 9 and 10. These are the 4 options. Now maximum value of x, y will occur when both x and y are equal. That means x and y are 3 each. X, y will be 3 into 3, 9. So maximum value of x, y is 9. X, y can never be 10. So this point, 4th point is very important. You will be asked that the value of given expression can never be, and then out of the 4 choice you will have to mark that choice which is outside the range of maximum or minimum value of the given expression. This 4th point is important because the question will appear to be totally unrelated to this logic, AM is greater than or equal to GM. The question will appear to be totally unrelated, but it would be a question from this topic in disguise. Lastly, there will be questions where reciprocal terms will be involved, such as x upon y and y upon x. Now on multiplying the terms, everything will get cancelled and you will get a constant value. You will get a constant. Now when product is constant, minimum value of sum could easily be calculated. Okay? I hope these 5 points are clear to you and you will be able to pick up these subtle clues. This topic is light on theory, as all you need to know is AM is greater than or equal to GM. But at the same time, this topic is very important for CAT. Many questions have been asked in previous years from this topic, so get down to practice, solve a few questions to gain confidence in this topic. Thank you.